Announcing the arrival of Yang Berbahagia, Profesor Dr. Raha Abdul Rahim, Vice Chancellor of UTM, accompanied by Yang Berbahagia, Profesor Datuk Technologies Dr. Muhammad Ghazali bin Muhammad, Deputy Vice Chancellor, Academic and International of UTM. Yang Berbahagia, Profesor Dr. Zulkifli bin Ibrahim, Deputy Vice Chancellor, Research and Innovation of UTM. Yang Berusaha, Dr. Rustamrin bin Jenang, Dean of Faculty of Mechanical Engineering. Yang Berbahagia, Profesor Dr. Ghazali bin Omar, Professor in Faculty of Mechanical Engineering, as well as Deputy Director in Advanced Manufacturing Center of UTM, senior officers and distinguished guests. The Negaraku will now be played, followed by UTM Terbilang. Audience, kindly please be seated. Honorable guests, ladies and gentlemen, to bless our blissful occasion, I would like to call upon Ustaz Muhammad Ali from Pusat Islam to lead the Doa recitation.
Assalamualaikum warahmatullahi taala wabarakatuh. A'udzu billahi samil alim minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, ya Tuhan kami, di pagi yang penuh keberkatan ini kami berkumpul dan berhimpun bersempena dengan Majlis Syarahan Umum Pelantikan Profesor 2019 ini. Kami mendadah tangan memuji dan bersyukur di atas limpah rahmat dan nikmat serta hidayah-Mu kepada kami. Ya Allah, ya Rahman, kurniakanlah kami taufik dan hidayah-Mu, pemikiran yang benar-benar mantap, hati yang penuh segar dengan keikhlasan, serta bimbingilah kami ke arah menuju umat yang benar-benar bertakwa di sisi-Mu. Ya Allah, ya Rahim, Engkau hiasikanlah kepribadian kami ini seperti kepribadian kekasih-Mu Nabi Muhammad sallallahu alaihi wasallam. Engkau jauhkan fitnah dan kekacauan daripada kami. Engkau perbaikikanlah perselisihan antara kami. Engkau pandukanlah kami untuk mendapat jalan yang lurus, dan Engkau bersihkanlah pekerjaan kami selama ini. Sesungguhnya Engkaulah yang maha berkuasa lagi maha mengetahui. Ya Allah, ya Allah, Engkau perkuatkanlah ukhuwah antara kami. Jadikanlah organisasi kami sebuah organisasi yang cemerlang, yang dapat membina masyarakat yang berilmu ke arah mencapai wawasan negara. Semoga dengan wujudnya majlis ini akan dapat meningkatkan kualiti pekerjaan, mengeratkan hubungan silaturahim di antara kami, dan seterusnya meningkatkan tahap kecemerlangan akademik untuk agama, bangsa dan negara. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma. ولا تجعل فينا ولا معنا شكيا ولا محروما ولا مطرودا. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم. والحمد لله رب العالمين.
Thank you, Ustaz Muhammad Ali, for the Doa recitation. Before we proceed to our next agenda, we will be having a group photo session. All the honorable guests, speaker and participants are kindly advised to be remain seated. Yang berbahagia Profesor Dr. Raha Abdul Rahim, Vice Chancellor of UTM. Yang berbahagia Profesor Datuk Technologist Dr. Muhammad Ghazali bin Muhammad, Deputy Vice Chancellor, Academic and International of UTM. Yang berbahagia Profesor Dr. Zulkifli bin Ibrahim, Deputy Vice Chancellor, Research and Innovation of UTM. Yang berusaha Dr. Rustam bin Janal, Dean of Faculty of Mechanical Engineering UTM. Yang berbahagia Profesor Dr. Ghazali bin Umar, our honorable speaker for today's event, senior officers and distinguished guests, the organizing committee members, beloved participants, ladies and gentlemen. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and salam Melaka berwibawa, pintar, hijau, bersih. It is my great pleasure to welcome all of you to the second 2019 UTM's inaugural professorial lecture. Honorable guests, ladies and gentlemen, Alhamdulillah, with the grace of Allah the Almighty, we are blessed to be able to gather here for today's event organized by Faculty of Mechanical Engineering. We are here to celebrate the achievements of Professor Dr. Ghazali bin Umar as our honorable keynote speaker for the second 2019 UTM's inaugural professorial lecture. Honorable guests, ladies and gentlemen, now we are pleased to invite Yang berusaha Dr. Rustam bin Janal, Dean of Faculty of Mechanical Engineering, to deliver his opening remarks and followed by profile introduction of Professor Dr. Ghazali bin Umar.
Bismillahirrahmanirrahim. Yang berbahagia Profesor Dr. Raha Abdul Rahim, Vice Chancellor of UTM. Yang berbahagia Profesor Dr. Ghazali bin Omar, our honorable speaker for today's event. Yang berbahagia Profesor Datuk Teknologi Dr. Muhammad Ghazali Muhammad, Deputy Vice Chancellor, Academic and International of UTM. Yang berbahagia Profesor Dr. Zulkifli bin Ibrahim, Deputy Vice Chancellor, Research and Innovation of UTM. Yang berbahagia Profesor Madya Dr. Nurul Fajar, Deputy Vice Chancellor of Student Affairs, Senior Officer and distinguished guests, the organizing committee members, below participants, ladies and gentlemen. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and salam Melaka berwibawa, pintar, hijau, bersih. On behalf of organizing community members at the host faculty, I would like to express my gratitude to all who present to MAJLIS SYARAHAN UMUM Pelantikan Profesor Series 2 2019. MAJLIS SYARAHAN UMUM Pelantikan Profesor is part of annual academic and knowledge sharing platform for professors in UTM. This is the third time that Faculty of Mechanical Engineering has been selected as the host. We are thankful that our college Professor Dr. Ghazali bin Omar has been given the honor to deliver his keynote lecture for this session. It is a great pleasure for me to introduce our speakers today, who is going to talk to us about the continuous development of wearable electronics by focusing on superconductive polymer composite. Wearable technology in microelectronic devices is emerging as important application for future flexible electronic display, robotics, multifunctional electronic textile, energy harvesting, and many other applications. Professor Dr. Ghazali bin Omar graduated with a doctorate degree in 2004 and Master of Technology in 1997. Both from University of Malaya in the area of advanced material in semiconductor technologies. He received his Bachelor of engineering mechanical degree in 1989 from Victoria University, Melbourne, Australia. Throughout his year of service in industries, Prof. GHAZALI has received a number of awards, including series of Motorola Silver Seal Award, on Semiconductor Technical Excellence Award, and the most prestigious is the Prime Minister Award as Malaysian Best Employee of the Year in 2002. Prof. GHAZALI, with his distinguished industry career for over 25 years, has established himself as a principal consultant in the area of advanced materials in semiconductor and microelectronics, with extensive experience in teaching, researching, and developing technology breakthrough in collaboration with university. To date, he has established 51 technology-based R&D, professionally served 37 companies on 39 series of technical training, 61 technical consultation. In his interest and competency as a strong research characteristic, he also voluntarily supervised 4 master students to completion, closely mentored 21 university research programs. As a result of his research interest, he has published more than 50 articles, journals, and academic papers. During his tenure with industry, he has successfully secured 25 million ringgit grant from mostly now as MESTEC. He joined UTM under Faculty of Mechanical Engineering in April 2015 after serving multi-industry for about 25 years. Since the last 4 years, he has been masterminding the formation of Advanced Material Character Research Lab, or MCAR, as an integrated lab among 13 members of different research groups within COE CARE. He has successfully elevated this lab as one of the most successful industry demand-driven labs, with strong collaboration from various industries in Malaysia through securing research grants, service contract, and consultation works. Under his leadership, AMCHAR has collaborated with CREST, Class Highway, MPOB, ASEAN NCAP, Nano Malaysia, Erasmus, AMIC, CALSEM, Petronas R&D, and Semara to receive monetary through grant and service contract amounted up to 3 million for 2019. Currently, Prof. Dr. GHAZALI Omar is the Deputy Director of the newly established F1 Manufacturing Center, which will be the first high COE candidate for M10. Honorable guests, ladies and gentlemen, on behalf of the faculty, we are very proud to have Yang Berbahagia Profesor Dr. GHAZALI bin Omar as our faculty member, and with this opportunity given to him to deliver his keynote lecture entitled Evolution of Superconductor Polymer Composite in Wearable Microelectronic Devices. We hope this keynote lecture will enlighten and inspire us. May we all bring from here not only knowledge, but also better effort for open, rich, effective communication and cooperation that should be good. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Yang Berusaha Dr. Rustam Renjana for smooth opening remarks, unveiling and inspiring biodata of Professor Dr. GHAZALI. Honorable guests, ladies and gentlemen, now that we have learned how Professor Dr. GHAZALI sailed through his success in life and career, let's watch and enjoy a multimedia presentation which shares the origin and colorful past of our prominent speaker. Honorable guests, ladies and gentlemen, now we come to the pinnacle of this morning ceremony, the moment all of us have been waiting for. After we have a brief introduction about the vast experiences that Prof. GHAZALI has, especially in electronic industries, I'm sure it managed to spark our interest in his expertise field. With the advancing of today's technology, it is no doubt this lecture comes at the right moment and time. So without further ado, it is with great pleasure that I would like to invite Yang Berbahagia Profesor Dr. GHAZALI bin Omar to deliver his keynote lecture entitled Evolution of Superconductor Polymer Composite in Wearable Microelectronic Devices.
Thank you, MC. Yang berbahagia Datuk TS Dr. Muhammad Ghazali Muhammad, Deputy Vice Chancellor Academic International. Yang berbahagia Datuk Zulkifli Ibrahim, Deputy Chancellor Vice Chancellor Research and Innovation. Our Dean, Dr. Rustamrin Jenal, and then also Senior Officer, my boss, Dr. Abu. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah rabbil alamin. Wassalatu wassalamu asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Alright, a little bit nervous on today, but then I try my best to deliver this. Alright, this topic that I choose is something that I think is very much needed for the industries. It's very much needed for us as a university, that if we want to say that we want to collaborate with industries, and these are the one that actually we want to have. So that means it's not going to be a very sustainable research, but also something that is going to be expanded. All right, and thank you very much for a lot of members from industries that actually attending this kind of conference. This talk today. Okay, evolution of superconductive, maybe a little bit exaggerated, superconductive polymer. Wow, even sometimes metal also cannot be superconductive, but now polymer can be superconductive, and it's a composite in the wearable and microelectronics packaging. All right, so let me see. All right, so the content that I'm going to talk today is on the reality of the wearable and flexible technology. What actually the strategic plan in developing this kind of technology, right? And how actually we're going to do networking with industries, because to me that, as a product, if you don't have the customer, if you don't have actually waiting customer or confirmed customer, it's not going to be a product, right? A lot of things actually we do is say we're going to have a product, but then the product itself won't be sellable or won't be commercialized if actually there's no industries going to take up this kind of thing. So this is really kind of principle that actually I'm really believe, right? Being in industry before for 25 years, and I'm going to talk how actually we talk about superconductors, polymer composites, and then how actually we're going to achieve this, and then what actually kind of our strategic research plan and so on moving ahead. What actually we're going to do about it, and maybe if time permitted, I'm going to allow a few questions from the floor to ask if any things that actually you want to ask this kind of topics, right? Okay, as a part of introduction, I think we started understand about electronic device when actually transistor last time, talking about how actually with the replacement of cathode diode with the transistors, and people talk about transistor radios, these sort of things, and then the technology go to this kind of VLSI, all those very complicated devices, millions of transistors in one particular device, and everything still in the rigid. That's actually the kind of technology that what actually we used to believe and we used to know and we used to have. We're still having it now. But then talking about this emerging technology, right? It's not something that actually impossible when we talk about things actually in electronics. Not has to be rigid. Imagine that actually you want to have a display to be a kind of whatever shape that you want to put in your car, in your helmet, whatever actually. So it needs to be flexible. Imagine that the solar panel that a lot of people don't want to use it because actually it's just one flat panel covering your roof, which actually you want to have certain texture. But then this kind of things soon right? You know, if we actually strive to it, you know, it's not going to be something like impossible. Everything actually can be, you know, following whatever the shape that actually want it to be, you know, as long as actually it's wearable and flexible. That's what actually, you know, the most important thing. But then, okay, this is something that we have to understand how actually in terms of the concept, in terms of the technology that you want to do, make it actually possible. All right, okay. I'm not going to read the slide because I use the slide as a guidance, and then but then I just want to talk what actually, you know, striking in my mind on this kind of thing. All right. All right. So, you know, understand this actually when we talk about handphone last time. Initially, you know, you can just do the communication, one-way communication. You cannot do the WhatsApp. You cannot do even the SMS, so on. Right. Motorola is the first one, you know, come up this kind of thing, very big, you know, until you think that you can pour the water inside this one and then, you know, have a bottle to drink it. But then, you know, because of the evolution of technology, and then at the time, Motorola don't believe, you know, this kind of handphone can be applied to young people, students, and then, you know, they think actually, you know, it should be very close meant for the working staff, so on, and then they lose the market because this kind of partnership is not really happening. But then, you know, evolution of technology, you know, on this kind of things, they make actually, even you have a phone, but then you just have this kind of USB or, you know, kind of wireless communication. And nowadays, Atelic, you know, in terms of wearable, they have all this gadget to put on their body to make sure, you know, what actually kind of health condition, you know, they have in this country. So that means people, the coach can really monitor this kind of what you call it, the performance, and how to improve this kind of thing. So this actually already happened, right? But of course, you know, there's still a bottleneck, a kind of obstacle that they have. How actually to make this to be even wearable, flexible, people can use it even without really worrying too much about it, you know, and then don't feel like there's obstruction in yourself. You can just wear things that you want to wear, and people don't even realize that kind of things. This is something that actually evolution of technology, especially in the microelectronic industries, people are really pursued to this, you know. Everybody actually is like a competition racing, you know, where actually we are, how actually we want to go there. And we are lucky actually we have people from industry, Dr. Shutesh, actually, you know, working on this kind of technology that I know, you know, Interconnects, and then also Dr. Azman Jala from UKM, who actually also working on this kind of advanced material, you know, in terms of Interconnects, working on this kind of thing. And then, you know, we have to be together, you know, because we are the technical university. And that's where actually I always say that actually we're not going to formulate, we're going to apply whatever already available in the market, and how actually to make it something that, you know, very wearable and something that very good to be used, right? Okay, so in the future, you can name it whatever actually you want. You know, name tag's not supposed to be, because, you know, nowadays people don't want to wear name tag because they say, you know, going to damage my clothing, you know, something that actually is not good, sometimes lost or what, you know. Imagine that, you know, later maybe you think going to be the first who going to have a digital name tag, right? You got this kind of thing. You know, we introduced as a first university to have digital name tag using this kind of wearable technology, right? You know, it's something, it's not impossible, it can be possible, right? Because we have kind of technology, but of course, you know, in terms of functionality, reliability is still not to the limit that we want to do this, okay? Right. In terms of market, you can see this, right? No worries, right? This market actually is just a projection. If you look at this kind of thing, the market, you know, based on this current one, you're going to have this kind of very, very steep kind of expansion. Right? This talking about wearable, not talking about flexible. I think in the industry we talk about billion, 3-digit billion perhaps, you know, it can be happen. So it's nothing joke about it, as long as actually the technologies in the world, including in Malaysia, specifically to UTM, right, we strive to work on this kind of thing. Alright, so what actually, you know, when we talk about wearable, when you talk about flexible, you know, what actually is all about? Okay, I want to give you this kind of understanding, right? Wearable, flexible, I don't have. It's not like, you know, you can bend, you can flex, you can crumple it, and then it's still functional, like what I show it here. Okay, and then, you know, none of the material can do this kind of things if they are not polymer. They must be polymer. They must be polymer. You know, you cannot just crumple metals. You cannot crumple ceramics. You have to do it polymer. But knowing actually polymer is covalently bond, right? In the primary bond, they are covalently bond, meaning that actually the electron has been used for sharing. When actually, when they covalently bond, electron, when actually they bond among atoms, in the hydrocarbons, hydrogen and carbon, right? The electron has been used up. So there's no electron they're going to use to have this kind of mobility of electron. Okay? So there's no mobility of electron. How actually they're going to conduct electrically? Okay? That's actually the problem, right? When actually you want to have this kind of flexibility in the polymer. Thanks. Okay? When you want to have this flexibility in the polymer, you won't be able to do this. Unless, okay? I mean, when you want to do this, the base can be flexed easily, right? The base can be flexed easily. No problem, because you want it to be insulated. But what actually for those conductor, right? Covalently bond, and then you're not going to have electron anymore to conduct. That's where actually you have to use something to add into this one as a composite, but then electrically good. Even can reach to the superconducting kind of performance, right? Okay. Well, before I go further this kind of thing, the technical part of it, which is kind of boring perhaps, I want to show you how actually I arrived to this kind of thing, right? This actually because when I want to do this kind of, I did a little bit of survey among the members to say, what actually I should talk? So you want to talk technical, like you talk in the class, right? All this one is a very, very senior people, very mature, very what you call it, experience. You want to teach them, then you forget about it. So tell us about the process you do in order to do this. Show what actually the experience base that you have, how actually you put the strategy in order to make this happen. Even with very short time, about 3 years, because of course few months that I stay with the UTM, I little bit of dangling, try to get connected, like within 3 years. How actually I arrived to this kind of thing, and then get the people to work together with us, and then make the lab as one of the very maybe I self pride one of the very successful. Thank you to the members. I think we have a lot of members here. So loyal to this kind of research, right? And also I have a very good mentor, Dr. Abu. Is actually mentoring me. Right on the management side. Okay. Why actually? I have a strong interest in this kind of thing. Okay. Do we have the right process to do this? Because we say we want to do the right process. Do we have equipment to perform this kind of activities? Right? We understand about the fundamentals, the physics, the chemistry behind all this kind of thing, right? And do we have the people? If we have people, actually, are they fully trained on this kind of thing? This, when we talk about the capabilities is not just about having equipment, but having all this kind of infrastructure. And then, as what I said, if we want to have this to be a product, do have industry partner. We don't want to do things and say, oh, this is a very good product, but the industry, look at us. Is it a product? Can we use this? Is it something that actually we want to sell? Can we commercialize? It's going to be a problem. That means whatever actually we want to do, we have to get the spec from the industry. Industry say, I want to have this. I want to having this kind of problem actually currently, and then please help me. That's where actually they give you kind of specification of what actually the product that they want. That's where actually you will be, working with the team. Oh, industry want this. Let's work on this one. So that means. Whatever the product we're doing is not for yesterday one, but then for tomorrow or for future technology. So that's what actually. So of course, with my 25 experience, I don't want to waste that experience. When actually I come here, I say, I'm not going to be like what actually a fresh, because I'm a fresh professor, they call it. I want to make sure that actually I establish my forte. In this kind of work. So I have to make sure that I'm not going to waste 25 years of my learning, with the multinational company, 2 American-based company and 1 European-based company. So vast experience, right? If I don't use this to help our university, then actually it's going to be something like a waste of my experience. So what's the point of having life if you don't continue your momentum to the way that you want to be? I remember that actually our mantan MC, Datuk Sharin, actually asked me, what actually, why actually you want to join university? And I told him, I want to have a quality life. And people actually laugh, perhaps laugh, when actually quality life. Quality life actually is not something that actually, things that you want to relax, enjoy the university environment, but want to do what you love to do. That's what actually, I want to have quality life, because in the industry, industry can agree with me. It's not something that whenever you do the R&D, the D is big, the R is small. The R is small, the D is big, because it's a profitable organization. Of course, no point to do research if you cannot develop the product. But university actually we develop, we do research. We are not actually having all the facilities to develop the product. That's where it's the marriage, alright? So this is what actually create me the interest to do this kind of things. That's where actually I want to do. So that's what I mentioned. Okay, I work with the National Semiconductor Now Texas Instrument in Malacca for 7-8 years, right? And then I work with Motorola on semiconductor in Seremban for another 7-8 years. And then I work with Infineon Kulims, right? For this one, all has to do with interconnect material. Because actually the devices. If you have a problem with the interconnect, none of them actually going to function. The whole board going to fail, right? Even one circuit, even one transistor in million of them fail, right? So you have to really look all this kind of interconnect material. You have to really check my time, because sometimes when actually I talk, I cannot stop talking. That's a problem. All right. So these are actually, I work with a multinational company. Learn a lot of technologies, a lot of something that actually imagine that when you work microelectronics, it's not electronics, microelectronics. So whatever works is not microwave anymore, it's nano. Right, because if you don't understand nano in microelectronics, then actually you actually kind of waste of your effort to understand why actually certain things behave in certain manners. Okay. Okay, I just use this. All right. So when I talk about interconnect, this has to do with interconnect. Everything that we do, has to do with interconnect. Imagine that actually wire bonding, right? Where actually you have to do solid state diffusion. We learn about joining techniques, and then we do the soldering, another kind of diffusion, and then we do the chip level component attach, right? And then we use epoxy. This actually just to make sure certain mobility of electron, V equal to IR, right? If actually you push in voltage, the electron need to be mobile, need to be transferred from one place to another. Imagine that actually if your interconnect is not good, then you cannot move the electron. So electron is not mobile, then you're going to have problems. Okay, so with the 3 companies that I work here, I have this kind of experience. We develop wafers. Like, if maybe many of you may not understand electronics, like we develop the engine of the car. We develop the engine of the car, make it perform the way that it wants to perform, and after that we send to assemble. Sorry. We need to assemble the car where actually, you put all the parts to make sure. So that means you need to do this kind of thing. You cannot put the Ferrari engine into the Proton car or whatever. So you have to make sure the product, the device that you have has to be connected, right, with the right package and something. So this is something that actually I've been working for the last 25 years, right? Okay, and even my PhD research has to do with the interconnect, where actually I study about the solid state diffusion between the wires, because welding conventionally people say it's fission welding, but then we don't use fission welding, we use a solid state welding. That means the two material are in the solid state manner. We look at the wires, we look at the grain structure and so on. These kind of things actually took me 7 years to complete my research, right? So it's kind of something that actually I learned a lot of things about the technology of interconnect before I want to venture in this kind of things. All right. So of course, I always believe that if we are engineers, we cannot just work on the engineering functional properties without understanding on the material aspect of it, right? So always, whenever I do things in terms of engineering functional, I always relate back to the material part of it. How actually the material be able to explain certain functionality failures or certain functionality performance of the devices. There must be a chemistry or physics or science behind it. How actually they can be explained. That's why actually, right, if you see my first degree in mechanical engineering, but then I did my master in PhD not in mechanical engineering anymore, it's in science. Because when actually I work on certain development. I remember the time copper wires. I have difficulty to solid state diffuse the copper into this kind of thing, and I do not know the science behind it. And then I said I have to learn more. Right? I thought that my mechanical is enough to explain everything. That's why actually, right, I understand science. Yeah, I took another 7, 8, 9 years to complete my master and PhD. So that means I understand. So when I teach material to the group of people or the student here, I always talk about, have you seen atom? I said, no, I've seen atom. Oh, I can see atom because atom in the textbook is like round. I said, no, you know, that's a textbook. But then, you know, what actually the level that we say, nano, this kind of thing, that actually we can see the grain boundary and then the lattice, right? The arrangement of the atom, like tungsten silicate here, and then we know the spacing, the space between the two atoms. We go down to that level, right? We study those. And, you know, in the devices itself, especially like MOSFET, metal oxide semiconductor field emission transistor, we have the gate oxide just about 3 to 4 nanos. We study those right to that level. So, but of course, there's a science part of it. Whenever we see failures like this, whenever we see okay, so okay, the same thing, like, you know, when you want to have the things like this, right? We talk about polycrystalline and then amorphous structure. You know, we know, but then how actually they behave, we do not know. So this is a kind of thing that actually we'll be able to explain in detail, the science part of it. Okay, so whatever the failures that we have, right, we have to understand very well. You know, when we talk about interconnect, these are things, you know, my line of work and the experience that I have, we have to look at all the detail, how actually it functions, where actually the failures, how to interpret science, what actually cannot think. So because imagine that actually if you buy the product, handphone or whatever, right, one small component having the wire broken, right, the whole product actually is failures, right? Just one simple things, right? So that's why actually always when I work with the industries, I just don't talk about functional, I talk about reliable, because, you know, no point having the product to be functional, but if they're not reliable, there's even bad reputation, right, when it's introduced to market. Right? Okay. So I was offered to join university. Firstly by UKM, of course. My seafood, Prof Azman, you know, sorry that I cannot make it, right? But then my faith actually that, you know, I joined UTEM. So I thankful also, I think, you know, that God has given me the right path to join UTEM, because of course UKM, they have all the seafood hardcore, right, to change certain paradigm of doing things not easy compared to UTEM. I think I still can recruit young lecturers to keep this. Okay, so, you know, this is not something like a title. I don't consider the title, I consider this as a responsibility. So how am I going to take the responsibility? It's not just, you know, oh, I'm a professor now, I can, you know, I'm a professor, so what? Professor is just a professor title, but then the responsibility. So I really do this kind of searching, you know, to understand what actually, I think I got off this. So it's a kind of understanding. I asked around. I asked Prof Azman, Professor is what, Prof? What they can do? So he explained to me. And I asked also, what professor must have? And then, you know, I understand people from Japan, they said, in Japan, in order for you to be a professor, you must have your lab. Without the lab, actually, you're not professor. Wow, I must have a lab. You know, I'm new. So this kind of thing. And then they said, actually, you have to lead a large research team. You have to foster the research of other groups. That's why actually I became the manager for COE. Right? And then you have to attract research resources. Right? That means, you know, income. You have to get grant from the university, from the industries. And so that's what actually been doing. Okay, so you have to work on the major research project. So I take note of that. Okay, it's not easy, I say, but I want to do it. I will do it. Then I think I can do it. So this kind of thing that actually, you know, lead me to the title that actually I want to discuss today. You know, it's not something that I just say, let's do this one without putting a strategic plan to it. You know. So first of all, when actually I understand what is the role of professor and professorship, the said, well, if you want to have lab, I will have lab. I want to have my own lab without 100% approval from the group or not. I will have the lab. So you know, we develop, because as what actually can see my background, that actually I work on this kind of material. We have this kind of designing the comprehensive demand-driven lab for industries. That's what actually my charter. I think it's quite niche. That we have this kind of thing, right? And then we have this kind of to bridge the gap among the academia and the industries. That's what actually we want to have. Okay, and then we must have actually people from different kind of discipline. Because I told the members I don't want any duplication. Right? None of the members should duplicate their talent. You know, it should be from different. Because in engineering, to make it functional, to make it reliable, to make all these kind of things, not just on the material aspect. You have to look at all sides of it. Okay. So this kind of thing that actually we have to do, and then collaborate with all the people. And of course, actually we are quite young. We don't have the right equipment. We don't have enough equipment. We have right equipment, but not enough equipment. That's why actually we work with memos, right? We work with memos. I think it's humming. Then, hello. Okay. Then I go back to this. Sorry. So with that actually we told the people we don't have lab that have enough capability. Then we actually left, of course, actually, Dr. Shukri, we went to Mimos, right? Say, okay, you have the fullest one. Can we do the MOA with you? So that means we can be like a shared services. So I can tell the whole world that I have TM, I have OG, I have all those very expensive equipment. You really have? Yes, I have. We're actually in Mimos because we signed the agreement. So I use this kind of strategy. Alright, if you say I want to buy everything, and then offer management say actually you want to buy 5 million, what actually kind of ROI? I remember actually Datuk NC asked me when I want to buy ion polisher, right? What's your ROI? I said 3 years. But then not in terms of this one, but then the investment that actually I asked and how actually I put able to give back the investment, from the profit from the investment. Okay, so I went to see what you call it. There's a high impact PJP, so call it, right? Only professor can apply, so I applied. And at that time, I think Prof. Rabia, Dato' Rudin, and also Prof. Batrul, right? He asked me, this project actually not feasible, this industry project. You cannot take this kind of project, right? Because you should talk to industry. And then I said, please, I need the bait to go fishing, right? Without the bait, I cannot go fishing, right? I said, I cannot fish. I have the right gear. I have the fishing rod, but I need to buy the baits. Because if I go to the industry and ask for the money, the industry will ask me, who are you? Come here, want to ask money, right? So I need to buy the fishing bait. And if you look at the title of my project also, it still has to do with the, advanced manufacturing of electronic industry. So, of course, I managed to convince the panel, and they gave me the money. And straight away, with the members that we have, and the student, and for your information, 4 of these 5 students are graduated this year. 1 already graduated last year. So I think, although it's not GOT, but then something is okay. But then these are the things that we do. So immediately once I got the approval, right, I asked the people, let's go to Jebel. Maybe people know what actually the history with Jebel. So let's go to Jebel. And one thing actually I told Jebel, what? You have problems? Let me solve the problem. Don't worry about money. I have money. Like very proudly say actually I have money. So they said, wow, this guy must be something that asking for project that for free. Because actually most important this is what actually you want to have. Okay, I will tell you later in this kind of thing. So of course, once actually we get the money, we establish the lab. And then we mobilize our people to really work, setting up the lab, clean the floor, and use the recycled table. Because of course we know the luxury having this kind of thing. This table is meant to be the computer table last time, with the CRT tube, all this kind of thing. And then we say, okay, this kind of thing, just put the glass on it so we can use it. Until now it's still there and zero cost. and we just buy a little bit of partition, and after that actually we tool up our facilities, and these are the things that we have, you know, right? Our Pengurusi LPU has visited us, and many industries have visited us, this kind of thing. So it is very interactive. I don't worry, you know, and then feel shy to invite. Yesterday we have the Vice President of Netherlands Malaysia, Cik Murni, right? Okay, who going to do collaboration with us, visited the lab. You know, I told them this is what actually the lab. So I don't have to play like, you know, show and tell this sort of thing. It's just whatever they are actually in this kind of lab, and I told them what actually our strategy in doing this kind of thing, right? So we have from endowment, from we fix certain tools, and then after that actually we have some money. That's where actually our Dr. NC asked me on the investment, because there's a certain allocation. I'm the only one applied among the professor on this one. So of course, thank you very much for your trust. So this is what actually we have, and of course now we have the people, right? Because most important thing, people is an asset to any organization. You don't matter what kind of sophisticated tool that you have, no matter what kind of facilities you have, you don't have the right people to do it, then you're going to be in trouble. So we develop, I invite, ask them to sign in blood. One of them is our Dean of PPS, say that actually, you know, be part of my team, even though you can survive still on your own, right? Help me to do this kind of monitoring and also take the leadership role. So these are the people, young people, right? Very young people. Most of them are just graduated, and we develop this kind of talent, list of expertise in material and so on. Okay, so this is actually the exercise or the mechanism that I use in order to create my own lab, because I accepted the job as a professor, right? And then of course, in order to make sure the lab actually is sustainable, expandable for the future, I make sure that everybody have their own functional roles. Okay, not just to research, but then everybody have to play their role in this kind of thing. That's what actually we have here. Okay, and of course actually with this kind of thing, we have our postgraduate working on the graphene, working on the hybrid, working on CNT, working on the silver, working on all advanced material. So these are the people that we have, you know, as a postgraduate, right? And for the last 2.5 years or 3 years, right? These are the companies outside that we are collaborated. We have Plus here, we have what you call it, AMIC here, we have MIMOS, okay, we have not Kasem, Jabal, Malaysia, and so on. You know, there are I think about 20 so of industry collaborators joining us today. So this is something that actually we do, and of course, no point to tell this without telling what is the result of this collaboration, especially when it comes to the dollar sign, right? So this is what actually the grant that we managed to get, all right? So up to date, right? These are the things, okay? Of course, when we said 1.3 million, this from Crest still holding the money until now, right? Until I get the right or suitable company that actually I want to go. Because at the time they already gave me the letter of offer, right? Because of certain understanding upon the IPs, misunderstanding about IPs, so it's something that not be able to sign the agreement, even though initially agreed. But then, okay, the money is still there. I have to be very careful. I try to get by this cycle. By end of this August, should be able to get this. Okay, pray hard for this. All right. Okay. When I was sponsored for the Mevlana program in Turkey last 2 years, right? They know actually me from industry, and they said, Prof, I have a conference in our university, GHAZALI Technical University. Can you deliver the keynote? I said, you know, you're much better than us. What kind of keynote do you want to give me to give? They said, talk about industry collaboration, how actually to do the network, how to bridge the gap, because we know actually you're from industry. Wow, I said actually my members oversell my my capabilities, so I have to deliver. So I deliver. So this is a part of the slide that actually I give to them, you know, how actually to do this kind of what are the challenges in working. Like for example, actually we talk about the language. We talk that actually we communicate in English, we communicate in Bahasa, we communicate in Javanese, whatever word, you know, Tamil or what. But then actually still It's not just about the language, how actually you pass the message and then it's well communicated and then both parties understand. That's what actually you call communication. It's not just verbal, it's not just a text, it's not just body sign, but then a two-way communication, and then once you want to pass that message, that's especially well understood by the people. And how actually the strategy to go by this gap, right? These are the kind of expectation. When we go to industry, we talk about journal, and then actually people from industry, they talk about product, right? You talk about journal, they talk about product, and then actually I don't want a product, I just want a journal when I collaborate with you. And then people what they say, I don't care about journal, I just want a product, right? So there's actually kind of communication breakdown. So we have to understand what actually kind of expectation. And we studied a few industry, they are model. Many models actually they are used, right, in the collaboration, this kind of things. Like for example, we look at how MIT, Cambridge, or other university work on this kind of model, or they can work this kind of model, right, and then see how actually they do cross-functional. They have this kind of thing. But then, okay, these are what actually the model that's very important to do. Most important thing, how actually this model can be used to different company. You cannot just use same model. You can use different model for every different company that actually you're attached with, right? So whatever model that you use, if only work if you get trust. That's why Dr. Bazdan, right? When actually we meet, I said, I know that you don't trust us, right? Okay, don't talk about big money, right? Since you don't trust us, just we talk about small money, okay? Now actually we gain trust. We're not going to breach that trust, I promise you again, right? So we're going to go and move further, okay, and get collaborated and then produce the products, because I think it's that we have demonstrated to Plus that we have a product that they want, and we must make sure that not only functional but reliable. Okay, so the thing is a trust, right? In the industry we always say walk the talk. We walk the talk, because we don't want to trust the word. We want to trust actually what? The action. You say 1,000 words also, I can do this, I can do that, but then actually there's no action on it. People don't really want to understand this, yeah? Okay. Alright. Okay, there's some about how actually drive me to work with the industry in the technology based on my experience, based on what actually the responsibility given to me, which actually that also on the communication with industry that actually I've been exercised, because when I was in industry, university come to me, always, I see the weakness that they cannot communicate to my language, my industry language at the time, right? And of course, I have the boss to report. You cannot justify me how I'm going to justify my boss. Instead of putting a lot of effort to justify my boss, I just decline the project. Easy, the manner, right? So justification that you have to give to us, helping me to promote or to elevate this kind of concept given to me as industry guy, to my boss, is easy. Otherwise, I have difficult to convince. People say, are they capable? I do not know. So why actually you want to do it if you do not know? Then people look at me, this guy might be clumsy, don't do homework very much, just suddenly propose to me how actually you want to do. So I have to protect myself, right? So these are the things we have to understand. I want to tell you this, okay, being in industry. So well, too much mumbling about myself and my experience sort of thing. Okay, let's move to the topic that we're supposed to complete and understand this. Alright, okay, alright. So let's go back. Go back to the main topic of evolution of superconductive polymer composite in wearable microelectronic devices. Okay, right. We know that actually conductive polymer composite. Okay, this is something that polymer is polymer. You can buy the resin in terms of the what you call epoxy base, it's a PP, whatever, as long as it's one, right? So in order to make them to be conductive, most important thing, you have to put the conductive material inside there, otherwise it just be this one. Of course, actually polymer can be conductive with the modification of the polymer. Those actually in the polymer science or polymer engineering, they know they can be done. But then of course actually certain limitation that you want to have make it very difficult even to come out the conductive polymer expensive. So let's use the polymer composite. So polymer composite is a material that actually you can change that, right? For example, let's take a look in terms of the conductivity here, right? These are the metallic range, these are the insulating range, this is semiconductor range. Then what actually you want to have, right? Want to make sure that you have this kind of thing. You can make the piece semiconducting and also metallic range. So what actually you have to do? You have to add up the fillers. The fillers must be conductor, or even better, like graphene superconductor. So when you have a superconductor in that material, you must make sure that they have network. The network is something like when actually they reach to the certain percolation limit, where actually these material are engaging to each other. So that means you can diffuse or you can transfer the electron, which is a little bit mobile, to one to another. Okay, so this is what actually we said, we can reach certain conductivity when we have this, right? So a lot of people actually have tried with different type of fillers, different type of material to see how actually I can reach when I reach certain percolation. Certain things, with a certain filler loading, they are very late to reach the percolation limit. Percolation limit is the limit where actually they start to establish the network for the electron to pass through. Okay, so this is what actually we are working, and for your information that we tried many, I'll show you later. We have to use the metric as a binder. So we put actually conductive polymer as the material to perform the conductivity as long as they reach certain the conducting zone. This kind of network, that's where actually when you pump in voltage and you make it functional. Okay, but knowing that actually V equal to IR, if you do this, actually you have problems that a lot of surface interaction. When you have this surface interaction, it's going to be a problem that actually the surface itself create kind of resistivity. This resistivity will cause you to get even higher voltage to make sure they're conducting, because imagine that actually when you have the electron, right, and then electron go to the surface and then start to react, and then according to the first law of thermodynamics or conservation of energy, energy cannot be destroyed or created, but then it can be transformed from one to another. Meaning that actually electrical itself, if they have this kind of very high resistance, what will happen? They transform into heat. Heat is a #1 killer actually in electronic device. That's why actually you go to your CPU of your computer, they have a fan. Every day actually Dr. Shukri talk about how actually I be able to conduct heat effectively. Even Dr. Shukri also remember, right? We talk about heat dissipation, thermal budget, thermal management. Right? Even actually, right, we went to Kasem recently. They talk how actually I can transfer heat very fast. So this is not only on the functionality of electrical performance, but the functionality of the thermal performance. That's what actually we want to have. So of course actually we tried many fillers, not only one filler. We start with the carbon nanotube, carbon black, copper, silver, graphene, and that's one things that actually it's no longer IP, it's if I tell it here. But then it's part of my FRGS. But of course, like this is what actually we want. So that means this is not something that actually we say we want to do it. We have done it. This is what actually I get my people to do it. Go and then explore all the possibilities and get me the numbers. Because without the numbers, actually, I cannot decide what actually the direction that we want to go. So we work with carbon black, copper, silver, even the sintered silver, alright. Okay, my seafood Dr. Sutesh again, talking about the sintered silver, right? And then graphene. That's where actually we want to work with Nanomesia and also Kasem. I'll tell you about it. And I try to look at the eutectic gold silver. How much is eutectic gold silver? Because we know gold is very high temperature. Silver also high temperature, but when you do eutectic based on the phase diagram here, based on the phase diagram here, I can even reduce my temperature down to 300 plus, right? Instead of 1000 for this one, but then with the right composition, I can make it to be this one. Imagine that if I can make this into the size of the material, I can even lower down the diffusion for this one. So I reduce the thermal conductivity issue. Yeah. All right. So always, as I mentioned, has to do with the contact resistance. Wow. Right. Okay. I almost done, by the way. Alright. But then okay. Alright, so the contact resistance has to be improved, right? Imagine that actually, I always, when I teach people in the material science class, young students, they sort of think they don't understand this, I say, V ketuk I, what it means. I say, potential, voltage potential, I, resistance, I is current. So what is that in Bahasa English? I always relate to the arrows, right? When actually we have a river without arrows is like zero voltage. When you have very fast voltage, you drive the water very fast. That's where actually you apply very high voltage, right? And how you slow down these arrows? By putting a lot of stone. That's actually resistance. That's where actually you slow down the resistance, you slow down the arrows, and that's the thing. Okay, that's why actually people say which one is important, arrows or current? People say, I do not know. Of course, actually, the higher the arrows, the higher the voltage, the danger is going to be. That's why actually when you have this kind of power electric, people, they say actually not high current, they say high voltage, right? The high voltage is like tsunami, very fast, the flow of water, right? Until now actually you can cut things with water. Okay, so forget about this one. This is what actually you want to have, alright? So this is what actually things that you want to do. Okay, that's why when we talk about this, we understand the effect of filler loading and the aspect ratio of the multi-wall CNT to the volume resistivity. So few of my students working on this kind of thing, few of our students, not my student, our student in the group doing this kind of thing. And I get a member of one student to understand this, how actually the interaction between gold and silicon. The gold nanopowder and silicon nanopowder integrating together and make this actually working, right? And I can lower down the temperature and see how actually it works. So yeah, they are pursuing this kind of thing. We'll report the material and we're going to understand this apart from other things. Yeah. And we also work on the physical properties of material in terms of science, in terms of geometry, right? Apart from just a filler size, how actually things work, right? And then that's where actually we try to understand this kind of thing. Of course, we know that the size play important roles. Last time, you'll not be able to get nano size easily, right? Everything must be in micron. But with the technology that we have, right, a lot of particles can be in nanoparticle, and that's actually the beauty. When you have in nanoparticle, whatever diffusion no longer in the normal state what actually been dictated or be published in the textbook is no longer. You cannot follow the rules anymore because the surface to the volume ratio getting higher already. Then you're going to get a very good surface interaction rather than volume interaction, which is not needed. And then that's where actually you lower down the temperature. I think again, Dr. Sutesh, they're very well aware about this kind of understanding. And Dr. Azman, I think he talked to me many times about Prof. Azman. I talked about this many times when actually you become nanoparticle. That's where actually we're going to explore, right? And of course, with this kind of understanding about the shape and the size, and we do the reverse engineering. In the industry, we call it reverse engineering. If we don't understand here, actually we say literature review. Right, industry university literature review just based on literature, but then industry, our literature review or not literature is on the actual unit. That's our literature review, right? We review what actually other products because we don't want to reinvent wheels, so we want to leapfrog certain technology, and then we take supplier A, supplier B, as long as we don't disclose what actually the supplier, and we are okay to do this kind of thing. So we try to understand. They said, actually this guy said they're using silver particle, but then they use a variation of geometry and also variation of size within that material. They never disclose as part of the trade secret. That's why they get so good conductivity. Now we start to understand this kind of thing, right? So that's how actually we escalate our understanding about how things was done, right? And of course, synthetic civil, I mentioned before, these are things actually we want to do, and we not say we want to do, we are doing. Right, and then we got sample, and we understand how actually things, and we subject to this one. Okay, and what actually most important thing I want to show you this, for example, right? This is a nano size already. This is not actually micron, it's nano size. Right, when we diffuse silver, silver actually is quite high, it's about 600 plus. Right, they just start to diffuse at just even 200. Right, the material start to diffuse. What happens if in this particles of this one start diffuse, what will happen? Of course, you reduce the surface interaction, which actually generate heat, and of course, actually when you improve the surface resistance, you're going to have lower voltage to apply with it. Take note this one. You know, when you talk about all these devices, number one important factor is how you use your power consumption. Imagine that your handphone, every 2 hours you have to charge, because you know they have to drive the electron very fast and low resistance in it, right? So you want to have very low resistance. Low resistance, that means they are superconductor, right? This is actually the, if you have superconductor, that's where actually you start to work on this kind of technology. So in this way, actually we always talk resistivity, so that means we can improve the conductivity. Okay, so of course hybrid, right? We try to mix, you know, I mean like when actually you want to make a cake, so you want to make a muffin or what, you know, you try to mix things, actually say, what happens if I mix this? What happens if I make this? But we cannot just say what happened blindly. What happened based on certain literature or certain fundamental that we understand how actually things work. So we do the hybrid, try to understand how actually I can make it to be a superconductor kind of material. Okay, so a lot of exercise, a lot of things actually has been done by 13 plus another 13 of lecturers or researchers, another 13 of this one. We try to understand this. Okay, a lot of this. Okay, so what actually we work, you know, we try to understand on how those actually the mixing and formulation, how to deposit by sensor printing, how actually to do texturing, what actually kind of pattern, because any devices, they cannot be just one single line, they may be, you know, a type of any devices. So we work on this kind of thing, and we have established certain data how actually it should be done. Okay, and then we do the experimentation, you know, on the functional. We look at all this kind of 4-point probe, right, when we want to use high voltage, as what I mentioned yesterday to in our guest, that actually, you know, we want to see, you know, in this kind of thing, how much voltage that they can take in order for them to function or to survive, right? And then we do the in situ heating, because all the device, remember this, you know, a lot of works actually, a lot of paper established, they talk about room temperature. In reality, you know, to make device functional, it's not room temperature anymore. You put the car, you put anything, they experience certain temperature. So a gross one, we use a hot gun or even a hair dryer, right? Put on the sample and in situ measure the performance of device, right? And we do the lead joint also, and then we put, you know, kind of heat, and in order to understand this, we put stretchable things. That's where actually outside there, you see there's a number of products that actually we have come out from the market. That means there's no in the market. We come out ourselves, because whenever we want to study this, we cannot just buy things from the market in order to test. So we have to make our own jig, right? And then perhaps one day, if we can even make the jig to be more functional, we're going to sell. So of course, we talk back to the industry. If we can sell this product, it's going to be very useful. Okay. Of course, when we do this, we also talk about how actually to make this to be good in the surface properties, reliability, because most of the product we always say, oh, this device is functional, but after 3 days in the market, they're not reliable anymore. Imagine that, you know. That's why last time, you know, a lot of people say that I want to buy a handphone from China, like BlackBerry. I remember, you know, BlackBerry few thousand, this one only few hundred. But after that, you see all the sound, all the noise come out, you know, from this kind of thing, and people forget about it, right? Because it's not reliable. And if they sell this product again, people won't trust. So that's why actually I talk to any industry that I work. I cannot publish this as a good product if I don't get a reliability data. I have to make sure that it's reliable, because you cannot sell this to customers, say it's functional, and then they say U10 product is functional but not reliable. Imagine that kind of remark. We want to get grumpy or get upset, so there's no point, because at the time it's too late. So I asked the Professor, the NCPI, that I want to get the money to make sure this one reliable, much more than to make it functional. The cost of money to make it functional, you know, is this much. To make it reliable is even much more than what actually to make it functional, right? So this kind of concept that we do, right? I think Plus happy with that, you know, because we work on the rugged area. So this is what actually we are working, yeah. All right. So for example, when we stretch the material, of course we look at this kind of thing. right? How actually when you increase, when actually material stretch it, okay, and what actually kind of resistance and why actually this behave, and then we look at the microstructure, the structure part of it, how actually the disintegration of the fillers in the material make it to be this kind of performance. This is something that actually have to be fully understood. That's why in very early part of my talk I said I always integrate the engineering and science together. Okay, so the same thing. If I stretch this my polymer base, and actually I can start to see the dissociation of the fillers to be like this one. That's where actually this continuity of the electron to be mobile, right? This is something that actually surface resistance that we want to overcome. This sort of thing, yeah. I'm not going to elaborate in detail on this, right? Just managed to tell you. And then we check on the reliability of hygrothermal and see how actually the performance and what effect actually, and then we start to understand and discuss these kind of things, yeah. All right. And when we talk about the strength, the effect of this resistivity, we actually sometimes get surprised because we use same amount of fillers, same type of material, but then just different aspect ratio, we be able to differentiate this, right? Imagine the same amount of filler, same material, but then just the aspect ratio of the filler, sizes and this, and then we start to see differences. So there's a lot of physics behind it. We have to understand in order for us to understand how actually you want to make it more functional. Okay, cost, right? When we want to put this kind of interconnect material to the line, right, we have to make sure that they're always going to get adhered to the base. Without this thing adhered, no point. After a while, you're going to have problems. So, of course, we try to understand based on the Wenzel and Cassie-Dexter theory about the surface morphology, how actually to make this thing functional. Yeah, all right. Okay, I don't want to tell much about the technical. I think I talked to many seafood here, right? So okay, this is really the loading and also the aspect ratio as I mentioned. Okay, so this something that actually, if you want to know detail, for many of you actually want to understand this, always come to our lab, and then we can explain to you a lot of things pertaining to this kind of thing. For those actually my member or associate that want to understand this. Okay, so that's basically a little bit of exaggerated when I say superconducting polymer, but then actually relatively I can get polymer composite to have a very good conductor, which actually something that people are striving in this current technology, current world, and a lot of things actually can happen. A lot of product can be developed once actually we establish this in the market, right? So we don't want to be part of the entity to be left behind in this kind of technology. That's why moving forward, right? When one say moving forward, meaning that actually we just at the beginning, we are not the end. Our research actually is not something that we say one-time research and then after that go for another research and go for another. We want to make sure the research is sustainable and expandable. So that means people say where actually the niche, for example, right? Dato' Abu, where's the niche of UTM? Advanced manufacturing in the advanced material, for example, electronic material, for example. That's our niche, right? Of course, everybody, each one of us, we play our role, how actually we want to strive to whatever the competency that we have. But for this kind of groups, right, even though actually I belong to AMC, but then I have deputy chairman, Dr. Nur Azmi, actually, going to take the leadership, this kind of thing. We work together, and then we see the road actually straight, but it can be a lot of valleys, hilly area that you have to climb up hilly, and then the bending that you have to, sometimes you have to make U-turn, but doesn't matter. As long as actually as long as actually where actually your destination, where you want to go, doesn't matter what actually cutting, right? With a team, believe in your team, right? You work as a team, don't work in silos, you will be able to go in. So moving forward, right? This is what actually our plan for this kind of interconnects, right? We started, see this one, formulation, we have done that, we have created the ideas, and we develop facilities, grow the manpower, apply the grant, right? So we understand about functional properties, we understand about microstructure properties, and where actually now we want to go to applications, right? We want to go to the application, right? So I just want to tell you these stories, right? Cik Mundi, right? Okay, I mean, you know, she asked me yesterday, how you to manage to convince Kasem, which is a very hardcore. Initially don't want to take this project because Nano Malaysia said actually I can give you this project provided you able to collaborate with industries. If industry doesn't want you, I'm not going to give you money, right? So okay, I said let's go. So I and members, right, and Nano Malaysia, we went to Kasem, Kasem, right? Ipoh, Kasem S, and we told them actually I have something I want to show you, and the technology director, Miss Lily, yeah, very hardcore. You know, not hardcore say something, but then you know, so very firm. And then you know, initially they said I don't want. I tried with the USM, failed. I tried with Nano Malaysia 3 years ago, also not be able this one. So I'm not interested, right? So I said, you know, I came from Malacca to Ipoh, you know, for very this kind of thing. I promised that you know, whenever I go, I'm going to bring the sales. So I think I need to really convince. So what should I told them? Kasem is a manufacturing base. Can you project to me actually next 10 years what actually you want to be? Are you still going to be manufacturing base? I asked her, you know, ask the industry people. So I come here together with Nano Malaysia. We want to transform you from manufacturing base to technology based company. Right? I told people like that, right? And I said some more. And this technology, you are in the wrong side because when you talk about heat, because actually you know people misunderstood. She wants to use graphene, but she wants to use graphene for thermal, not electrical. And then I said, do you want to use thermal? Right? I cannot disclose this also because we're going to patent this. I have to use when I talk about, because you usually look at electron, but no more electron. We look at the phonon. Phonon? They said, what is a phonon? Then I start to goreng. Yeah. I also don't understand fully. Then after that I go back in Malaysia, read the book. Oh, I think I'm correct. This kind of thing actually. So I, you know, talking this kind of language to them. I managed to convince. Imagine that, you know, you don't need it now. I said, you don't need it now, of course. But then put this in the technology shelf. Whenever actually is needed, you don't be reactive. You are proactively put in this technology shelf. And then when people want this, you already have it because you own the IP. I told her like that. And then what actually she said, it's very simple. What? You spark my what? Someone tell me, you spark my interest. You spark back my interest. And then she, after that, agree straight away without worry about cost. Straight away, you know, fill up the form over the weekend and then give me on Monday. That's how actually I communicated with the people in the industry. Actually, I'm like actually a salesman selling ubat, you know. Right? People don't think they are sick, and then I tell you, actually you're sick. You know, I have a solution for you. These kind of things, yeah, right? So, because I'm an industry guy, I know how actually they think, right? So, any one of you that actually you want to go to industries and win the sales, right? Bring me along. I charge you very minimum consultation fee. All right. Okay. So this one actually we have. All right. Thank you. Nano Malaysia trust us also. You know, because this under graphene action plan, right? We talk to them, and very soon that perhaps you know it's enough time for us to sign the MOU over there together with this, and then that's where actually this kind of things is going to work, and where actually we're going to do on this kind of thing. All right. We have many phases because we go stage by stage, identify, constraint, we plan, and then you know. So this kind of thing that actually little how actually the kind of methodology that we want to do, right? So this is actually kind of thing that you know we are working together, and there's a lot more. Of course, there's a lot more project other than this because the topic of discussion is just on the interconnect technology. That's kind of product that actually, or this kind of technology that actually I'm presenting to you today. Up to date that actually based on the last 3 years, actually this kind of course this is what actually the university want, right? We talk about the journal. We have actually 4 book chapter, and about 20 conference paper. Okay, I think I thought that I still have time, right? But then don't worry, we can have time to for kind of question and answer. With that, I end my speech, my presentation today. So thank you very much for your attention.
Thank you very much to Yang Berbahagia Professor Dr. Ghazali for delivering an enlightening and informative keynote speech. With the possibilities that we have around wearable microelectronics, I guess the future of the electronic industries will keep on expanding, and definitely the sky is our limit, inshallah. At this point of time, our speaker will be accepting questions from the audience. If you do have any questions, please get to the mic provided on the side of the hall and introduce yourself.
Enter 2.
Okay, Dr. Ayatali.
Thank you, my friend. Very technical, very academic. And then I think you have 2 degrees, material engineering and electronic engineering. Because
Okay.
the way that you have presented. Okay, it's really very interesting. But can you explain how up to what stage now in terms of developing the new material, advanced material for the benefit of the industry? Because some of the materials that now is wanted or required by the industry is something that flexible but can still have some sort like stretchable, for example. And then we also have elastomer. Have you done any research on the elastomer, conductive elastomer, so that the elastomer can be some sort like elastic? Okay? And then up to us, how many projects or how many industries have been benefited from your research? Thank you.
Okay, all right. I think not one question, multiple question, but I answer it only one answer. All right. Okay. Take note that actually when one develop technology, being a technical university, we are not the RU, so we're not going to develop the material, right? The material actually let others develop. As engineers, mainly most of us are engineers. We only apply. So we apply those material, but in order to apply those material, we have to understand the material behavior itself. The characteristic of those material. That's where actually, when I look at the functional properties, I understand how actually those functional properties works, or why actually that functional supposed to be failed, right? And I understand those material. So your question about developing material, we're not developing, but we're developing the application of those material. Graphene has been there many times, many years, right? People develop, just a matter of whether they're going to get cheaper. CNT is there, silver, all that is already in the market. You can just simply buy, right? Because we're not going to develop, let the 4RU or what, develop this material if they want to develop. So we apply, but again, So when talk about elastomer, right? We actually don't then look at elastomer because we are using for electronic devices. Electronic devices, when you use this kind of rubbery through elastic, and then they have a lot of other properties. Like we want to have a very low K material, for example. We don't want to have any kind of hysteresis when actually we want to do this. And for example, that when we want to do for RF, for example, we don't want to have any noise background to act on this kind of thing. So we don't want to develop those material unless people have told me that the elastomer can be used. So I will apply it. Right, so in developing the material, as what I mentioned, I'm not going to develop, but I'm going to develop the technology, so that the application can be used on this kind of thing, right? We can discuss this in detail, because we are just neighbor, neighbor next to my room, okay? Alright, I hope it's okay, Dr. Tali? Okay. Alright, Dr. Fudel? I thought it's time you want to ask question. No?
Assalamualaikum warahmatullahi wabarakatuh. Very good morning to all.
basically I'm not the doctors, I'm not the people in the education, but I'm from the industries. Okay, I think the same as you. First of all, I would like to congratulate. I don't know about ni because I thought this pelajaran today but it's very technical. I lupa bawa nama ini. Okay, first of all, I would like to congratulate you on becoming the professor. And I think this is the first time I joined this kind of syarahan, and I think it's quite good, very technical and very informative actually. And bear in mind that I think you are Matrolan and also Matrolan alumni from Seremban juga. I think you should know this Mark Thomas guys.
Oh yes.
Yes. Okay. Alright. So and he's quite a semiconductor expert. Okay. And another one is basically congratulate to UTM juga. Because why? Because getting an industry expert to be one of the key members, it's different. Like, for example, by Professor just now, when you talk to industry people, different. And I receive a lot of like professors, academicians presenting the case to industries, and I was like, apa dia cakap ni? And industry is basically thinking about money, how to make money from that, how to develop further. We're not talking about research, but we want to talk about how to develop further the things that you guys have developed dalam university, the research you have developed dalam university. How can we develop further, and how to make money from that, and how can it benefit the people? That is actually the bridging yang tak ada sekarang ni. Very difficult. I've been to a lot of universities, but tak boleh. Memang I find out people cannot explain to me. Okay, people can say. So I think your strategy just now, talking to customer, is actually a salesman punya ni. It has to be a bit of salesman. Tak boleh talking about technical, people go, apa ni. But it has to be salesman. Then you can sell. It's actually selling your expertise to the industries basically. So that one is the thing that we have to learn. Okay. So the third one is basically been talking to a lot of universities. I found further that the dasar intellectual property of the university itself is preventing the product to be collaborated further dengan the industries. Some universities, bila kita go, because for me industries, there's three things that I have to satisfy the management. First, before you go to any agreement, it has to be the NDA, non-disclosure, before you can go further, because exchanging information is very crucial after that. Then after that phase, it will be commercial. Is this benda ni boleh di-commercialize tak? Because for industries, they want to commercialize. Benda ni bukan short sendiri, belajar je tak? We have to commercialize. Number one. Number two, technically is it viable? Betul ke boleh? Kalau my application is still on micro, you guys are providing a nano, I cannot produce. Tak boleh. That's why customer kadang-kadang ni because I'm also a semiconductor, so I know lah. But now I'm not in semiconductor. The third one is basically legal. That's where fail. Banyak fail. And recently we have a collaboration dengan university. One university, I don't want to name it. The engineers, of course, very excited. So we develop. Then after that, commercial kita dah nampak. Then lupa nak bring the legal. So when we start to sign agreement, university cakap macam ni, kita cakap ni, fail. So project aborted. So you waste some time. You waste our time juga, because the engineer said, alah benda ni senang je, why legal is so important? But legal is very important, because that's where bila benda ni dah produce, let's say lah, the benda tu boleh commercialize about 100 million. University akan cakap, where's my portion? Confirm je. But this legal is very important. Remember, legal is very important. It has to be table up front. So now my management say, go to legal first. See their dasar harta intelek. Macam mana dia punya dasar. And most of the dasar that we find out, very old dasar. And it doesn't allow the professor at the university to be moving outside to the university. Masih kurang lagi. So I believe, I'm not saying that kita ni still tak nak tukar dasar, but I think you should look at the dasar, whether it will encourage the industry to come in. Kita tak nak consultation, but we want to bring the product from the university, a good product from the university to outside. That's what I found out. Banyak benda tapi tak boleh. The recent one, kita close. Because why? A good product, but then you see say, I think after they nampak collaboration, nampak the commercial, I think we develop ourselves. Okay. So it's basically the agreement has to be upfront. So dasar tu must look at, so that benda tu akan allow a lot of collaborations. Okay. The fourth one is basically being industries, we have a lot of install bases. Okay. Sebagai contohnya, kalau I've been in industry for 20 more years lah, and serving a lot of industries, serving a lot of customers. I have the bases, and the people in industry said, apa lagi produk yang boleh buat? Alamak, saya cakap saya tak ada lah. So I start to scout dekat universiti ni, banyak scout universiti, and I told the university people, okay, I have the sawah sebenarnya. Sawah saya kering gontang ni, but saya dah tak ada padi dia, biji padi dia. So the biji padi is all dekat UOL. Meaning that you cannot sell the padi as a padi. You have to collaborate with the people yang ada sawah ni nak buat jadi beras. So the yield is higher. Compare jual padi, you jual beras. Jual padi, you jual padi satu kan. Bila you ada sawah, you akan jual satu ladang. I have the sawah, I don't have the padi. But you have the padi, you don't have sawah. Meaning that a collaboration must be done together. And we are willing to bring all those product kepada luar. And I believe bila I start pergi universiti, saya cakap banyak produk luar ni bagus. Somehow no salesman. Tak ada salesman yang pergi keluar. I know your KPI sekarang ni, industry KPI kan. We are more than willing to go in. As I have to be thankful. My bosses, my boss are basically the new bosses. They are basically R&D punya inclination. So that's why they set up R&D center. We have our own R&D center, but I don't have the equipment that you guys can probably purchase. FDIR semua tu, all those equipment are very good. So we are trying to collaborate. Kita tak nak beli equipment tu because I don't have the people asset, people that run. I cannot recruit people just to run a machine, which I think I can use only once a year. Tak boleh. So I need university to help me to do this. Yeah.
Okay, thank you very much. Memang actually, whenever we go out, we never say actually we visit industry, we become a salesman. That's true, right? We always put our mindset that okay, let's go to do sales. Whether we can get sales. That's why actually once we not be able to get sales, initially we thought actually we can't say, we said very tiring. Spend time, not getting sales. We prepared, getting all the bullets, all the package to come and this one. Of course, the language that collaboration with the industries is very much needed. But do take note, I always advise the industries or the university that we are not manufacturer, so we don't want the product. Right? Let's you actually come out the product. We don't have the know-how, in terms of the processing the product, but we can provide the technology to the products. So of course, with the technology we have in the research, right? And then you come out the product, and with the certain IP that we share, royalty must be given to us because, right? That's us just to appreciate the effort that we have. Of course, but then say, oh, we can come up with our own product. Don't do that. Industry going to get upset with this kind of understanding that we have to come up with the product of our own, but we support the product with our technology and benefit from that product or from the technology is what actually we are good at, because we are university, we are not the manufacturing company, right? Okay, thanks. Any question? Yeah, Prof. My Sifu.
Assalamualaikum warahmatullahi wabarakatuh. Saya Azman Jalal dari Universiti Kebangsaan Malaysia. Saya ada beberapa soalan, tapi nak pendek kepada satu soalan yang agak penting. Sebenarnya bukan soalan pun, nak minta pandangan. Sebagai intronya, sebetulnya kami telah collaborate dengan Prof G, dah collaborate since 2002. Jadi saya percaya beliau lah begitu matang dalam akademik, dalam industri ni, tak payah cerita lah. Jadi melihat kepada industri elektronik di Malaysia, yang mana industri elektronik ini dah lebih 40 tahun, start zaman Minakaran dulu.
di Penang, di mana-mana ke, cari kampung, pergi ke kampung-kampung untuk cari pekerja. Tetapi saya melihat dari segi akademik kurikulum, sebagai seorang profesor di universiti, in term of research, dari segi penyelidikan, saya kira dah tak ada masalah sangat. Dan kita pun tahu, walaupun tak ramai penyelidik dalam bidang ini. Saya dengan Prof di satu bidang, kita ada daripada PELANTIKAN, USM, UMUM, UPM saya kira tak ada, UTM dan juga UTM. Yang ini dia researcher dalam bidang apa nama semiconductor atau electronic packaging begini. Tetapi keperluan kepada masyarakat dan negara itu adalah penting. Walau macam mana pun, isu yang timbul adalah isu kurikulum. Berdasarkan pengalaman Prof G sendiri, beliau graduate daripada mekanikal sampai dalam industri, banyak isu-isu yang berkait dengan sains. Ini isu dia. Dalam kurikulum, kita lihat apa graduate daripada elektronik, textbook yang digunakan mungkinlah ada 10 muka surat ataupun 10 helai di belakang tu yang bercerita pasal electronic material ataupun electronic packaging. Kalau dalam apa nama mechanical, kan, dia belajar all the mechanical, banyak sifat-sifat mekanik, tapi tidak belajar sifat mekanik yang perlu dalam electronic packaging. Begitu dia dalam material science, physics, chemistry, kan. Jadi dari segi kurikulum di peringkat prasiswaza, saya merasakan ini bukan lagi anak tiri lagi ni. Bidang yang sangat penting yang menjadi komoditi kepada Malaysia, yang kita ramai memerlukan pekerja, tetapi dipinggirkan dari kurikulum. Saya tidak tahu di mana masalahnya. Sehingga saya banyak apa nama dapat daripada industri bertanya pasal interconnection material. Intermaterial confirmation pun tak faham. Mereka tak faham yang sangat asas. Tapi saya faham sebab apa mereka tidak faham. Sebab dalam silibus sepanjang pengajian mereka tak jumpa. Masuk dalam elektrik industri terus jumpa. Jadi saya nak mohon pandangan daripada yang bagi Profesor, macam mana melihat apa isu ini dan apakah usaha-usaha yang boleh kita buat supaya menjurus kepada dasar kurikulum kita diperbaiki dan boleh support. Kalau mereka support, senang untuk kita buat research. Okey, sekian, terima kasih.
Okey, terima kasih Prof Azman, my good friend, dah lama dah. Alright, okay, this question memang dah banyak ditanya. A lot of people been asking this question. Of course, bila kita mechanical tu banyak sangat disiplin mechanical. But actually, it depend on the lecturers. Siapa yang lecturers mengajar tu. That's why I said, you know, whenever you teach the theory, you have to see where actually the application. Bila you mengajar welding contohnya, dia kata welding, dia cerita pasal mega structure of welding. Of course, betul. But then actually there's also nano structure of welding. That's where actually things actually have to be there. There's a lot of university that they call me to teach, like UITM, even University Malaya, UKM last time, teach on this kind of packaging. But that not on the undergraduate, but the postgraduate subject. To make this one, I think actually unless you are very specific to the school of microelectronics, and then of course very detailed. But otherwise, you know, there's a lot of application. I don't know how actually they can be part of the syllabus. But then, you know, as long as the lecturers, that's what actually I told the young lecturers, don't teach by the book anymore. Just the theory from the book. Define the lecturers on the application based on your research, based on your industry experience, especially from MTK, they have a lot of experience. Do that. Right, if you are from industry, every single processes and every single assembly can be translated into what actually microelectronic industry is all about. And then, you know, yeah, it's true. Electronic industry is one of the most important export for Malaysia. And we've been there for many, many years. But then, again, you know, our company is still manufacturing. We don't learn about technology because but then, you know, I think there's a different forum that we want to discuss about it, right? We can discuss. I think this is something that actually can be part of the national agenda to discuss, right? Thank you, Prof. Okay, I think it's the last question been told.
So I'm afraid that's all the time that we have today for our Q&A session. If you do have any further inquiry, we are sure Prof. GHAZALI will be more than happy to get to you personally. We kindly hope Yang Berbahagia Profesor Dr. GHAZALI to remain on stage for a while. Now, we would like to invite Yang Berbahagia Profesor Dato' Technologist Dr. Muhammad Ghazali bin Muhammad, Deputy Vice Chancellor, Academic and International of UTM, and accompanied by Yang Berusaha Dr. Rustam bin Janal, Dean of Faculty of Mechanical Engineering, to present a memorabilia to our honorable keynote speaker, Yang Berbahagia Profesor Dr. Ghazali bin Omar. On behalf of the organizing committee, we would like to thank Yang Berbahagia Profesor Dato' Technologist Dr. Muhammad Ghazali bin Muhammad, Yang Berusaha Dr. Rustam bin Janal, and Yang Berbahagia Profesor Dr. Ghazali bin Omar. Honorable guests, ladies and gentlemen, we have come to the end of the second 2019 UTM's inaugural professorial lecture. We would like to invite Yang Berbahagia Vice Chancellors, all our guests of honors and beloved participants to proceed for luncheon. On behalf of the organizing committee, we would like to express our highest appreciation to all who present today. Thank you. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh.